Hello students, this is a continuation of the ordinary differential equation topic under which we are learning about exact differential equation. Now here they have given a question and they have asked us to solve it. So solve y dash is equals to 3x squared minus 2xy the whole divided by x squared minus 2y. Now here we have to first bring this equation in the form m dx plus n dy equal to 0, and after that we have to check whether the given equation is exact or not. So if it is exact, then we have to solve the exact equation. If it is not exact, then we have to find the integrating factor and solve it. So let us first rewrite this equation. Now y dash can be written as dy by dx is equal to 3x squared negative 2xy divided by x squared minus 2y. So cross multiplying on both the sides, we get x squared minus 2y, and then dy is equal to, when this is cross multiplied, 3x squared minus 2xy dx. Now bringing this term to the other side, we can rewrite this as, so we can write this as 3x squared minus 2xy, so this term dx, and then when this is brought to the other side, it will become negative x squared minus 2y dy is equal to 0. I can also rewrite this as 3x squared minus 2xy dx plus 2y, because when I take this negative sign inside, it will become minus x squared, minus into minus will become plus, so it will become plus 2y. So I am rewriting it as 2y negative x squared dy, so that I will be exactly having this in the form m dx plus n dy equal to 0, where the value of m is this and the value of n is this. So we have to take that and write. So m is equals to 3x squared minus 2xy, and the value of n is equals to 2y minus x squared. So now we have to check whether the given equation is exact or not. So if it is an exact equation, then dou m by dou y will be equal to dou n by dou x. So if this condition is satisfied, we say that the given equation is an exact equation. So now let us check this condition. So to check the exactness, now we will take m here. So m is 3x squared minus 2xy. So what will be dou m by dou y? It will be equal to, now partially differentiating with respect to y. So x will be treated as constant. So this whole term will become 0 on differentiation. And here we have to treat minus 2x as constant, and the differentiation for y is 1. So here we get negative 2x. Now here when we come, dou n by dou x we have to find. Now here y will be treated as constant because we are partially differentiating with respect to x. So this whole term will become 0 on differentiation. And here we will be having negative 2x. That is differentiating x squared, we get 2x. So we have a negative sign here, so minus 2x. So we observe that dou m by dou y is equal to dou n by dou x. Therefore the given equation is an exact equation. The given equation is an exact equation. So now if this is an exact equation, then we have to proceed to solve it. So because it has satisfied this, we say that the given equation is an exact equation. So if this is an exact equation, then there exists a function capital F such that. So if you see the previous problems, you will understand this more better. So there exists a capital F such that dou f by dou x will be equal to m, and dou f by dou y will be equal to n. So there will exist a function capital F such that dou f by dou x, partially differentiating this f with respect to x, will be equal to m, and dou f by dou y will be equal to n. So using this, now if we see here, dou f by dou x is equal to m. So let us substitute m there. So dou f by dou x will be equal to, the given m is 3x squared minus 2xy. Now this can be rewritten as dou f is equal to, taking this dou y here, we have 3x squared negative 2xy dou x. Now integrating on both the sides. So when we integrate on both the sides, we get integration of dou f is f, that is equal to, now here we are partially integrating with respect to x, so y will be treated as constant. So the integration of 3x squared will be 3x cubed by 3, and then minus 2y is a constant, and the integration of x will be x squared by 2, plus, now because y is treated as constant, we will be having a function with respect to y which is independent of x, and so therefore capital F will be equal to, simplifying this further, we get this and this will get cancelled, so we will be having capital F to be equal to x cube minus yx squared plus f of y. So this will be our solution, but we have to find this f of y to complete this solution. So now we have to find f of y. Now how we will be finding this f of y? To find this f of y, we will be using this concept. So that is dou f by dou y is equal to n. Now f is what? This. So dou f by dou y will be partial differentiation of this function with respect to y. And so from this we get dou f by dou y. So we have to differentiate this partially with respect to y. So x cube will be treated as constant. So on differentiation it will become 0, and then yx square. So with respect to y, when we differentiate, it will be 1 for this, and minus x squared we will get as such because it is a constant, plus the differentiation of f of y will be f dash of y, and that is equals to n. So what is our n? The given n is 2y minus x square, so that we have to substitute here. So 2y minus x square. Now from this, f dash of y will be equal to 2y minus x squared. So taking this negative x to the other side, we'd get plus x square, and so these two will get cancelled, and so f dash of y will be equal to 2y. Now we will be integrating on both the sides with respect to y. So f dash of y dy will be equal to integral 2y dy. Now when we integrate this with respect to y, the integration for f dash of y is f of y, and that is equal to, now 2 is a constant, so we can write it here, and the differentiation of y dy is y squared by 2, and so this and this will get cancelled, and therefore the value of f of y is equals to y squared, and so we have obtained the value of f of y. Now this f of y has to be substituted here to get the final complete solution. So now we have to substitute this over here. And so therefore the complete solution is capital F is equals to x cube minus yx square plus this f of y, when we substitute it becomes here plus y squared. Now writing it in the form of a general solution, how do we write? So phi is equal to x cube minus yx squared plus y squared is equals to c is the general solution of the given exact differential equation. Hope you have understood how to solve an exact equation. Thank you.